area and volume. Surface area is like you're taking the sphere and you're doing what to it? Good luck wrapping it, right? All right, and then volume is like you're doing what? Filling it with water, yeah? Okay. Now next, the vocab words. Guys, don't write down the definitions. You've got this. Know what a sphere is? Perfect. Draw yourself one. If I'm feeling fancy, I put a little like, da, 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 to make it look 3D. Like a bowling ball. That's it. All you need to know about a sphere. Do spheres have radiuses or radii? Yeah, they do. But it's right in the center of it, right? Right in the center of the bowling ball, out to the edge. Speak of the devil. Radius. Did you draw yourself a sphere? Yeah. I'm going to put this. So let's draw a radius in there. It's kind of hard to make it 3D. Oh well. So here's our radius. From the center of the sphere out to an edge. How many, the plural for radius is radii. How many radii are in a sphere? Infinite. Keeps going, right? Okay. Chord. This is a circle review, right? Chord. Does it go outside or does it stay inside? Inside. Edge to edge. So just draw yourself a chord. Check, check. It's got to go edge to edge. That's a chord. And then diameter. Diameter has to go through what? Center. Could diameter technically be a chord? Yeah, totally the chord. It goes edge to edge. Absolutely a review. Hope you're feeling confident. Good enough? Next part. Great circle. Oh, I'm not very good at drawing. Have you noticed yet? At least I try. Okay. Sphere. You could use the old one or you could draw yourself another sphere. Good luck. Okay, eyeball the center. Maybe right here. Okay, great circle is when, all right, you've got a bowling ball. You take a machete and you cut through it, and then you lay the halves like this. On top of this half is what shape? I'm totally giving it away. So it's a great circle. When it's got cut, it's a circle, but it's a circle that's perfectly on line with the center. So I'm not very good at drawing this. Usually it turns up looking like an eyeball. It's like here to there. That's the great circle. It's like that very thin slice that goes right through the diameter. It looks like an eyeball. It's supposed to be a circle. Great circle. So it's like you cut it right in half. It's going to be a circle. The shape of a circle. It's called the great circle. It's called the great circle because it's the biggest part of the sphere. The biggest circle that's part of the sphere. Okay, hemisphere. Do you know what hemisphere stands for? Please tell me you've heard that before. Okay, hemisphere is half of a sphere. Hopefully you know that already. Half of a sphere. Okay, that's our vocab. We were really nice to ourselves. Here we go. Formula. This formula is for what though? Surface area. All it is 4 pi r squared. What does the r stand for? That's it. You're going to be okay with that formula? Okay, you got it? Let's practice. Oh, guys, put a huge star by this question. Like, huge. So it says, find the surface area, but then it has a follow-up question. When the radius doubles, does the surface area double? Here's why I had you put a huge star by it. This question, every year I've taught geometry, this question has been on the geometry CRT. Every single year. Every single year, about 50% of my students get it right. That's it. Let me show you why. Let's go to the first part first. Let's find the surface area. So this little radius is 3. Surface area formula isn't just 4 pi r squared. Okay, let's be nice to ourselves and let's just leave it in terms of pi. So that's going to be 4 pi times 3 squared. You guys, what's 3 squared? 9 times 4. All right, final answer, 36 pi centimeters squared. Feel pretty good about that? Okay, take this. The question says when the radius doubles, does the surface area double? How many of you say yeah? How many say no? No. Can you prove it though? Can we double this literally and find the surface area? Let's do it. What's this radius double? Okay, so let's find the surface area of a sphere with a radius of 6. So that's 4 pi times 6 squared. Sure. What's 6 squared? 36 times 4? 144. All right, answer that question. Did it double?
No, it's more.
Who said that? That was brilliant.
I said it.
Tyler. Tyler, it didn't double at what? It quadrupled. It kind of tricks our brains. We think if we double something, it'll also double. But it gets even bigger than that. It quadruples. So here's hoping if it's on the CRT again this year, more of you will get it. Yeah? Now when it comes to CRT questions, when it comes to math questions, I know when I was your age and I had math problems that were just like that at the top, when the radius doubles, does the surface area double? And I wasn't given a problem, I was like, probably, and I just guessed. Is it okay to literally put numbers in there and test it out?
Oh, yeah.
Totally okay. Test it out, put numbers in there. Now, what if you're stressed for time and you're like, oh, I don't really have time to put numbers in there?
Well,
You always have time, right? CRT, I will give you as much time as you need. I'd rather have you be careful. Letter B, didn't we just find it?
Yeah.
So can we call again for letter B? Okay. Because look, we did it in pink, right? 4 pi times 6 squared. Thumbs up, you guys feeling okay about that? Thumbs up, how many things do you remember it's quadruples? Alright, we'll see. Watch it not even be on there this year. Here we go. This one, the circumference of a great circle, so the biggest circle in a sphere, is 7.4 pi feet. What is the surface area of the sphere? How are we going to go about this one? Allie, what do you think?
You have to backtrack the circumference to the radius and then put it into the...
Allie, perfect. She said we've got to backtrack using circumference to find radius. Whew. Do you remember circumference formula though? Good job, 2 pi r. What if you're like so cramped and you can't remember where you're going to look? Reference sheet. Okay, so circumference formula is c equals 2 pi r. Well, they gave circumference, right? So instead of the capital C, what number can we put? Let's put 7.4 pi right here. So that equals our 2 pi r. Now, Ali said we should solve for the radius. So how do we get rid of the 2 and the pi? Guys, what's so great about the pi's? They totally cancel each other out. So divide by 2 pi right here. Divide by 2 pi right here. It's fantastic because pi divided by pi is just 1. So radius is going to be 7.4 divided by 2? 3.7? Okay. Are we done? Uh-oh. Okay, we need that. Now what?
4 pi squared.
Yeah, 4 pi r squared. So plug it into the surface area formula. So we've got 4 times pi. What did we say? 3.7? 3.7 squared? Okay, will you tell the neighbor first? Check on your neighbors. Alright, hand in there. Will you tell me what you got for surface area on this one after plugging it in? Go ahead, Allie, thanks.
54.76 pi.
54.76. Oh, you left it in pi?
Yeah.
Perfect. And that would be feet squared. How many of you left it in pi, just like Allie? Might as well, right? If it doesn't say one way or the other, you can do whatever you want. Did anybody change it to a decimal? Christian, will you tell me what decimal is? 0.03? Alright, decimal people, do you agree with Christian?
Yes.
You got the same thing? Feeling okay so far? Sure, I'll take it. I will take a sure. Alright, let's do another. Volume. Here's a formula. It's just a formula. So 4/3 pi r cubed. No? Because it has a fraction. Is that why you don't like it? Improper fraction. Are they? Okay. Okay. Let's try to not get you so. Okay, this one, I'm going to change the directions. Is that okay with you? So, probably. Find the volume of this. Find volume. Okay, so volume formula, technically we're finding it for this. If you read the problem, it says that that cylinder has the same dimensions as the sphere. So sphere volume formula, you said you're scared because it has an improper fraction. That'll help me remember what it is. 4/3, is it pi r cubed? Okay, if those have the same dimensions, what's r? That'll be 5. So we've got volume is going to be 4/3 times pi times, I'm going to teach you about it on your calculator. Hopefully some of you already know it. Type in 5. you guys know the caret button? It looks like this. Doo-doo-doo. That just means to the power of 3. I think it's like kitty corner to the 7. Is that right?
Yeah.
Okay. Use the caret button. How are you typing in 4/3 though?
I just do ABC.
You're using the ABC one? Okay, so you could do 4 ABC 3, or could you just do 4 divided by 3 times pi times 5 caret 3? Okay, again, check on the neighbor first. How's your neighbor doing?
Jason, you doing well?
You're doing great, Cassie.
Okay, hand in the air, help me out. What did you get for volume? Tyler thinks, what'd you get?
166.67.
166.67? Seems a little bit little. Is it too little? Okay, let's back it up. And
Oh, wait.
0.6, and this would be centimeters cubed. Tyler, do you know what you did? I feel like it's gotta be something with the 5 to the power 3. That'll make it bigger.
That's in pi.
Oh, you gave us pi. Dang it, I erased it. What was it in pi?
166.67.
166.67 pi? Makes sense. Bam. How many? I'm okay. You doing okay? Feeling alright? Okay. Try these two, but if you read the directions, you need 2 answers on every one. Surface area answer and then volume answer. I'll write the formula so you don't have to flip back in your notes. Surface area formula 4 pi r squared. Volume formula 4/3 pi r cubed. Okay, go for it. Number 1, I left it in pi. Did anybody else leave it in pi? Do you agree it's 100 pi?
Yeah.
Okay. Excuse me. Number B, I felt 166.67 pi. Is that what you guys got?
Yeah.
Okay, what about the next one? Surface area 169 pi?
Yeah.
Volume 366.2-ish pi? How many of you just did pi and no decimals? How many of you did both? Perfect, perfect, perfect.